are live. Okay, so what is it? It's March. Yay! It's March. So our objective today is we're going to talk about polynomials. We're going to add and subtract polynomials. Grace, will you please make sure I don't go too fast? That's part of your job in here, huh? Did you get one? Okay, it's right down. So we talked about poly meaning many and nomial meaning numbers. So it's like many numbers, but we got to be more careful, more specific. For example, we talked about this. If I had x to the 1/2 power, that is not a polynomial because it has to have whole numbers. So it's terms with whole number exponents. X to the 1/2 is not a whole number. In fact, it's a rational number. We don't want this. That's not a polynomial. Degree of the polynomial is the largest. It's the largest exponent. And standard for it is just putting them in order. Order from largest to smallest exponents. So an example. May as well throw down an example. Oh, we have an example coming up. There we go. It's coming up, right? Monomial, one term. Binomial, two terms. Grace, tell me to slow down when you're ready. Am I going too fast? How am I doing, okay? Trinomial, three terms. And then we stop giving them names. We really do. We stop giving them names. We're not going to call it a quadnomial or a pentanomial or a hexanomial or a sexanomial. Oops, that sounds like a bad word, doesn't it? I don't want to invent these words. I just teach them, okay? Heptanomial, octanomial. That's just ridiculous. So anything more than 3, we just call it a polynomial. Does that make sense? So this would be a polynomial. Okay, more than 3 is just called a polynomial because it gets ridiculous. I mean, then we got to say something like a sexanomial. That just sounds terrible. Okay, more than 4, we just call it a polynomial. Okay. So if I look at example 1, first of all, it is a polynomial because there's 1, 2, 3, 4 terms. So this is definitely a polynomial. So let's rewrite it in standard form. So we go with the biggest exponent. The biggest exponent right there. Guys, you're back. We started. Plus, do you have your stamp sheet? You have your stamp sheet from, I collected stamp sheets, okay?
Oh.
So if you get your, and Oliver, here's your notes. If I get your stamp sheets, okay? So, rewrite in standard form, biggest exponent. So we're going to go P of x, and P of x means polynomial P of x, because our variables are x's. We're going to go 7x cubed, then the next biggest exponent, plus a 5x squared, plus the next biggest exponent, which is plus a 4x minus 2. What is the degree? Well, the degree is the biggest exponent, so the degree is right there. The degree is degree 3. Now the name, it's not a monomial, binomial, trinomial, but there's more than that, so it's got 4 terms. We're going to call it a polynomial. Now the leading coefficient, after you get it in order, coefficients are the numbers. Coefficients are the numbers in front of the variable. Coefficients are numbers in front of variables. And I'll let you get caught up because I'm going too fast on it. So 7 is a coefficient. 5 is a coefficient. 4 is a coefficient. The negative 2 is called a constant because it's not going to change. It's no variable. Does that make sense? So these are my coefficients. The leading one is the one in front after you rewrite it. So 7 is my leading coefficient. Okay, so my leading coefficient, this one is just 7. We'll eventually graph these. And polynomials, yes.
Is 7 the leading coefficient because it's first in standard form or because it's the biggest number?
Because it's first in standard form. You said that so well. Because it's first number in standard form. Not because it's the biggest. Great question. Because it could be any number. 10, 5, 1, 0.5, right? Now, why do we learn polynomials? Eventually, we're going to graph these. And polynomials are curvy. Okay? They're curvy, okay? And then in business, we can see tons of applications of polynomials in business, right? There's a business model. Okay? Mr. Davies runs a nice latte business, right? And then he gets confused because he can't know what to charge. Right about here, we hire Scott to take over because Mr. Davies can't do it, and then the business takes off, right? Do you see how polynomials could be a business model? All right. Now, you return the page. So this should be fairly easy. Adding like terms. So when we add, don't add exponents. Okay? Don't add exponents, add like terms. So I like to do this. You don't need to write this down, but I like to do this. What's in the bag? What's in the bag? How many x cubes? If I add 2 more x cubes, what's in the bag?
5.
There's no x to the 6's. You agree? It's just how many x cubes. I know it seems really obvious, but when you add like terms, right? And you don't have exponents. Okay, you guys put those phones away. Phones away, right? Phones away. So I'm going to put 3x cubed and a minus 4x cubed together and put these two together and I get a negative 1x cubed. I'm going to add a 2x squared with a 2x squared and get a positive 4x squared. It's this easy. And we're going to put together, here's another color. Here's orange. I'm going to put my negative 5x with my 3x and have a negative 2x. And I'm done because you only add like terms. That's my answer. Okay? Thumbs up. Seem pretty easy? Now subtracting polynomials is just subtracting, but you have to be careful. So there's 2 ways to do this. I'm going to show it 2 ways. Okay? I make mistakes. You guys know that. I make mistakes all the time. Well, one way I can do it is this. I can go, this one minus this one is a negative 3x cubed, agree? But here to here, I got to be careful because I'm going to take a negative 3x. I'm going to subtract a negative 5. See that? I'm going to subtract a negative 5. And then this 7 to this 8, I'm going to go 7. I'm going to subtract a negative 8. So if you can do that and not make a mistake, awesome. What I like to do is bring the negative through because I'm subtracting this whole thing and then add. I like to do it in 2 steps. Okay? You learn that way too? I do. So I'm a little worried because this negative goes through the whole thing. See how that works? So I do this in 2 steps so I don't make a mistake because I'm so good at making mistakes. So I'm going to bring my negative through. So I'm going to bring my negative through, and I'm going to rewrite the whole thing as a 4x cubed minus a 3x plus 7 minus a 7x cubed minus a 2x squared plus a 5x plus an 8. So I brought the negative through, and now I'm not going to make silly mistakes because I'm classic for making silly mistakes. And now I'm going to combine like terms. So like an x cubed with an x cubed. So I'm going to have a 4x cubed minus 7x cubed makes a negative 3x cubed. In order, right? This is my only x squared. Agree? Negative 2x squared, that's the only one, so I'm going to write down my negative 2x squared. Negative 3x and a positive 5x, there's a positive 2x. And then finally 7 and 18 makes a positive 15. Okay? I like to bring the negative through if it's subtract. I tend to make mistakes, but if I bring it through, then I don't. Okay? Okay, example 3 is the same way. The first thing I'm going to do is I'm going to bring the negative through. I'm just going to bring the negative through before I do anything. I'll rewrite this as a negative 3xy, a positive 4xy squared, a negative 5x squared y. Okay, now I'm going to bring down my first group. So all I did is I brought through the negative because I can see my double negatives. I tend to make mistakes again. That's why I do this. You don't have to. If you can do this in your head without having to rewrite it, that's fine. Just don't make a mistake. Oops, I almost made a mistake right there. Plus 1xy. Now, I'm going to combine. Well, let's see. I have a 3x squared y, which is different than an xy squared. These two, 3x squared y and a negative 5x squared y, are the same. I'll have a negative 2x squared y. I've got a 5xy squared, and I think that's the only one, right? I think that's the only one.
It's supposed to be 4xy squared.
Oh, I made a mistake right here, didn't I? Scott, thank you. Me make a mistake? Never, huh? Thanks, Scott. Okay, so how about 9 of those? Thanks, Scott. I almost made a mistake, didn't I? Well, I did, but you corrected it. These two are the same, right? These two are the same. And so I have a negative 2xy. Now, before I finish, standard form. Okay? These two technically are tied. Degree 3, degree 3, degree 3, degree 3, right? So you can put them this way. See degree exponent 2, 1, right? Degree 3, 1, 2, degree 3. That's fine. I might rewrite it because of the subtract. You wouldn't have to do this, but oftentimes we would. If it's a tie like this, we would often rewrite it as a 9xy squared minus a 2x squared y minus a 2xy. Okay, and again, these two are the same. Neither one is right or wrong. Yes, Tava.
Would you rewrite it because it's bigger or like an actual like positive number?
Yes, because of the positive number.
Okay.
Not because it's bigger. Great question. Great question. Okay, so homework today. It's not going to be hard. Page 37. We're going to do 9 through 20. It won't take long. We've got plenty of time if you guys want to talk about the egg drop or find a partner. I might give you Friday to work on it.